Hey guys, today I'm going to show you how the movement works in my game. So you'll notice like we have a grid. How does each fighter choose where to move on each grid? This is just going to be the first part. The second part, I'm going to go a lot more in depth into the algorithms, but this one will be a wide overview of how they work. So first off, I'm going to need to explain some concepts to you. So we have a graph or a grid. And what this is this is just a ton of vertices. So you can see right here we've got, oh, where is it? We've got vertices. So the whole graph is the whole thing. I'm gonna alternate between graph or grid. So this is graph, and then we've got this one thing, which is a vertex. I also call that a node. So it can be a vertex or a node, and also like this is a vertex or a node, this is a vertex. And then these little arrows are called edges. And what edges mean is they are going to tell us that vertices are adjacent. So if we have vertice 1, vertice 2, vertice 3, 4, 5, 6, that's a 5. That's a 5. 9, 10, 11, 12. We go 5. Vertices 5 and 6 are connected. Now, I'm going to do something slightly different than this setup. It's going to seem like I'm doing, 5 and 6 are connected, 1 and 5 are connected, but it's actually going to look like this because I am setting an edge between every single vertice. This is called an adjacency matrix. And all it does is I go, is there an edge between 1 and 1? So if we do an adjacency matrix for vertex 1, we go, is there an edge between 1 and 1? Which would look like this. And it does happen sometimes, but there isn't. So we go, okay, so let's put in 0. Because we are doing a true-false, basically. We go, if it's 0, there's an edge. And if it's 1, there's not. So for between 1 and 2, we go yes. And so we're going to keep doing that. And so we go, there's no edge between 1 and 3, 3 and 4. There is between 1 and 5, so I'm going to go 0, 0, 0, 0, 0, 0, 0. Now, this may seem overcomplicated to do, because why don't you just keep edges between them and not have some sort of and not have all the edges around there and just go, if it's 0, then we can't use that edge? Well, that's because what we need to do is, let's say I want to add feature functionality to go, let's move from 1 to 7. Well, then I would need to come up with something to create that edge and then remove it after it's done if it's only like a single use functionality. But in this one, all I do is I change the number 1, 2, 3, 4, 5, 6. I would change this number to a 1. And boom, that's a 0. It would work like that. So that's sort of why I did it. Now we're going to look into what the fighter is thinking when it has to move. Now that you hopefully understand these terms. So this hunter, its fighter, is going to need to go, there's enemy fighters here and here. How do I know that? Because I cheat and there's walls here and here. So all walls do is, you remember the 1s and 0s? We just make the edges between here and here 0. So that's another easy thing that we can use that for, because we just go set it to 0, and it doesn't believe that there's a path here, which there is not. So what happens first is, first off, the fighter will attack. You can see in the code, each tick we will go through the player team and do an attack, and if they don't attack, then we do a movement. Because if they didn't attack, then that means that they have no one to attack. So we also would do the same for the enemy team. So the biggest thing for this is you have to check if they are in range. Now, how they check if an enemy is in range is, let's say this guy, he has a range of 1. What he's going to do is he's going to go, is there anybody here? Anybody here? Anybody here? Anybody here? Anybody here? Any enemies here? It has to be enemies. And then he'll go, no, there doesn't seem to be anybody in here. So now I have to move. So they're going to skip this. This is a big if statement, so they're just going to skip it. And then they're going to go, okay, now we do the movement. That function's a little farther down. There it is. And it will do a little validation and then go to move character. And then what it will do is it will grab the indices to attack from. So let's say this fighter, he's got a range of 1. And we know, due to my understanding of the game and who made it, we know that there are 2 fighters down here. Now, each fighter has adjacent spots. So this guy, Rufus, is going to go, I need to go here, 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 and go here. He can pick any of these spots. So what he's going to do is he is going to, and by the way, if the fighter has a larger range, then they can pick this spot, they can pick this spot, they can pick this spot, because these spots are all farther away. It says the indices to attack from depending on your range. I think everyone here has 1 range. So let's go back a bit. So now, where will this guy go? I think that's Steve. Where will Steve go? Well, first off, he's going to go, so these are the indices I can attack from, and then we'll use our special Dkjstras algorithm, which I'll explain in the second part of this. And so he goes, okay, so I need to get a little closer. I'll move here. So this is 1 distance. This is 2, 3, 3, 4, 2, 3, 4. So these 2 are equidistant because it goes 1, 2, 3, 4, 1, 2, 3, 4, and it will count the spaces. These 2 are equidistant, and so what will actually happen is I can make it random if I want, but right now these grids are numbered 1, 2, 3, 4, 5, 6, and then it goes 10, 11, 12, 13, and then it numbers them like this, 20, 21. So it will take the lowest number. So right now we would expect him to go there because that is farther to the left. It's a lower number. I think this is 54 and this is 56. So let's see where he goes. Remember, we think he's going to go there. Now, right now, where do we think he's going to go? Because it has changed now. Remember, the adjacent spots are now here, 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 here. No, that's not adjacent. So now, what happens is this algorithm will run every time the person moves to a new square. So as soon as he got here, it ran, and as soon as he's here, it's going to run again. So now these have different distances. What is this? 1, 2, 3. So now it will choose this one right here because it's got the 1 in it. It is the closest distance, and you'll see this guy is doing the same thing. Let's see where he'll go. So this guy will go. Let's see where his adjacent. Let me just get rid of all this. This guy has this, 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 this. He's got these spaces he can attack from. 1, 2, 3. So, fun fact, when he was choosing where to go, he had these spaces. And so these spaces are what? 1, 2, 3, 1, 2, 3. And he chose this space up here because, remember, they're numbered and they will choose the smallest number if there's a choice. So that's sort of how the movement works, and in the next episode I'm going to explain to you how we find the path exactly, because Dkjstras algorithm is pretty long and I want to be clear on how it's used. So that's it. Like and subscribe, or don't. Live your life.